All right, welcome to Physics Essentials. This video is a video on distance and displacement. Before you get too much further, I would pause this and do two things. One, please make sure that you've got your learning targets sheet in front of you. There are a number of targets for this video, and you need to make sure that you understand them. And the second thing I want you to do is make sure that you've got a notebook or paper or something so that you can take detailed notes on this. Again, you should be taking notes just like you would do in a usual class. If I have something written on the screen here, you want to make sure that you copy it down because it's useful information. If there's something that I say verbally that is slightly different than what it says on the screen and that makes more sense to you, then write that down. The expectation is that you should be writing down all definitions, all examples, all of that kind of stuff. And the super cool thing is, because this is internet-y and video-y, you can pause, you can rewind, and do what you got to do to make sure that you're getting everything you can out of this video. Take advantage of those features. All right, very good. So here we go. We're going to learn now about the difference between distance and displacement. So distance, symbol for distance is lowercase letter d, as you can see here. All right, and distance is the total length of the path that an object follows during some time interval. All right, displacement, the symbol for displacement is this. It's a triangle and the letter x. All right, it actually is the Greek letter delta, which means change in, x, which means position. We'll learn more about that a little bit later on in the video here. But anyway, what you need to know at this point is when you see these two symbols together, a triangle and an x, you should think, oh, that means displacement. All right. So anyway, the definition of displacement then is that it's the length and direction of the straight line from an object's position at one time to its position at another time. Okay? So I think the best way for this to make sense to you is to do an example. So I'm going to do that in just a moment. Before I do, I want to point out something important, which is this. Both distance and displacement are measures of length. Both of them are indirectly kind of telling you how far your object has moved. And they just sort of make those measurements in different ways. All right, and I'll explain that again in an example. So right now what I want you to understand is both distance and displacement are measuring kind of the length that your object has traveled. All right, and because of that, the units for them both, for both of those two things, are going to be the same. All right, the units for both distance and displacement are any unit of measure that you could ordinarily measure length in, right? So what are some things you can measure length in? You could measure it in meters, you can measure it in miles, kilometers, feet, inches, and then other ones that aren't on here, right? Centimeters, light years, I guess. So when we talk about distance or displacement, we're going to measure these things in meters, miles, that kind of stuff. All right? So probably the best way to help you understand the difference between the two things is by doing an example. Before we do, I'm going to call attention to the fact that distance is a measure of the total length that you've followed, and displacement is a measure of the length of the straight line. Okay? So notice I kind of tried to color code things here and kind of emphasize the important points. All right, so let's do our example here. All right, so here we've got this ant who's sitting here. He's just kind of hanging out. I don't know if you guys can hear the music through my speakers here, but so anyway, suppose the ant is sitting on the screen here on my smartboard, and he's going to crawl from point A to point B. All right, so there's a couple different ways he could do this. He could, walk in a straight line from point A to point B. We're going to have him do something a little bit different, which is this. He's going to walk in a big, long, curvy, windy path, all right, to get over here to point B. All right, so if I'd traced that path, maybe the path that he followed looked something like this. Whatever. He didn't walk in a straight line. He was all windy and weavy. Okay? So if I wanted to measure the distance that my ant had gone, well, you know what? I should color code this, right? I did distance before in red. So my distance then, d, my distance then would be the length of this straight line. Okay, so I've drawn this on my smartboard, so it's pretty big, but if you imagine sort of this black line here is a piece of string, and then I grab the string here at point A, and I grab the string here at point B, and I pull it straight, and then I use a tape measure to measure it, then I can figure out how long that line is. All right, so on my board here, it looks like it's pretty long, so it might be, I don't know, as long as 10 or maybe even 15 feet. Let's call it 15 feet. Now, obviously, on your paper, it's going to be significantly shorter than that. All right, but so anyway, the distance is the length of this whole curvy line. All right, if I was somehow able to measure this whole length, that would be my distance. All right, now displacement is a little bit different. Okay, displacement remember, that's the length of the straight line from start to finish. Okay, so if I was to connect points A and B with a straight line like this, from point A to point B, the length of that dotted line that I just drew there, that would be my displacement. All right, so the distance is the solid line, it's all curvy. Your displacement is the length of that dotted line because it's a straight line from start to finish. All right, so if I measure this on my board, it looks like it's, I don't know, 4 feet maybe. Maybe we'll call it 5 feet. All right. So the displacement then is the length of the straight line from your starting point to your ending point. Okay. So there we go. So I want you to notice a few things about this. First of all, the distance cannot possibly be shorter than the displacement because the shortest path between two points is a straight line. Okay. In other words, if I'm going to walk from A to B and I want my distance to be as short as possible, then I'm going to walk in a straight line, right? So that then directly leads you into number 2, which says that the only way that the distance and displacement can be the same is if the object travels in a straight line. All right, that's going to happen. That's definitely something you need to know. I think that's one of the learning targets. You need to make sure you understand that if your object travels in a straight line, then your distance and displacement are the same. Okay. Thirdly, the only way that the distance can be 0 is if the object doesn't move at all, right? Because if my object starts right here, as long as he doesn't move, his distance is 0. But as soon as he moves even the littlest bit, he's going to have traveled some distance. All right. Now displacement is different. Your displacement can be 0 anytime you start and end at the same spot. Because remember, displacement is the length of the path from starting point to ending point. So if I start here and then wander around and come back to my starting point, then my displacement is 0 because the distance from my starting point to my ending point is 0. All right. One other quick comment about displacement is this. If you notice back here, this arrow, this dotted line, I don't know if you guys can see this here on your, whatever you're watching this video on, but there's an arrow over here on the end of this dotted line. Okay, so make sure you put that arrow in there. The arrow on my dotted line is meant to indicate that displacement has direction. All right, so the dotted line used to represent the ant's displacement has an arrow at the end to illustrate the fact that the ant started at point A and ended at point B. So unlike distance, displacement includes direction. All right, so in this case, we could say that the ant walked forward, we could say that he walked east, whatever. Usually in any given example, the direction will be fairly clear, but the problem is you can't put north, south, east, west, forwards, backwards into a calculator. So we are going to use positives and negatives to indicate direction. All right, and our positives and negative work the exact same way as in math class. Positive, negative, positive, negative. So depending on the context of the problem, we'll determine this. So if it's a problem where your ant is walking on a road that runs east and west, then east is positive, west is negative. If the road runs north-south, then north is positive, south is negative. It might even just be as simple as, you throw a ball up in the air. So if the ball is going up, your displacement's positive. If it's going down, your displacement's negative. And to be honest, a lot of the examples, I don't even really reference a direction. And so if the problem doesn't say anything about the direction you're traveling, then you can just assume that it's moving forward, which would be positive. And then if it says something about the object turning around, then that would be going backward, and now your displacement's going to be negative. Okay, so this idea of positives and negatives is going to become important as we move forward in our next couple examples. All right, so a minute ago I told you that if the object moves in a straight line, that your distance and displacement would be the same. You just need to be careful because your displacement might be negative. All right, and we're going to see that, I believe, in this first example here. All right, so it says, suppose Roy walks 4 miles west. So make a drawing. So here's Roy. All right, so he's going to start here. Oops. And then he's going to walk 4 miles west. So here we go. 1, 2, 3, 4 miles west. All right, so the distance he walked is the length of the path that he followed. So his distance is just simply 4 miles, right? It's not rocket science. His displacement, however, he did walk in a straight line, but he walked in a direction that was west. So in this example, his displacement's not 4 miles, it's negative 4 miles. And the negative is because he went west. All right? So now the examples will get a little bit harder. So here we go. We get another one. Suppose Roy. Roy is the guy I use in all my examples. So if you don't like the name, then I'm sorry, but you're going to have to deal with it. All right. So it says, suppose Roy jogs 8 miles west, and then he turns around and goes 3 miles east. So this time we're going to find the distance he traveled and his displacement. So probably the easiest way to get through this is there's 2 parts to his journey, right? There's one part where he goes west, one part where he goes east. So for part A, we're looking for the distance. All right, so the easiest way to do this is to just add your numbers, to go, all right, well, he went 8 miles, and then he went another 3 miles. So at the end of the day, he's going to say, gosh, I'm tired. I jogged 11 miles, right? All right, part B asks for the displacement, and we're basically going to do the same thing. We're still going to add those 2 numbers, but this time we've got to keep track of our direction. All right? He jogged 8 miles west. And since this is west, remember, west is this way. That's negative, right? East is this way. That would be positive. So when he jogs west, the 8 miles becomes negative 8 miles. And then 3 miles east is positive. So put a little plus sign here so you remember that you took it into account. And then add those numbers up. Now you got to know how to add positives and negatives, but since this is a science class, you can use a calculator, which I strongly encourage you to do. So grab your calculator, do -8 plus 3, and it gives you -5 miles for your displacement. All right, so that's how you do it. Let's talk about why you do it that way, though. All right, so let's take a quick second and make a drawing of what's going on here. What happened in this problem was Roy started here, so I'm going to put a little S for start, and then he walked 8 miles to the west. So 1, 2, 3, 4, 5, 6, 7, 8, right? So he walked this way 8 miles, and then he turned around and he came back 3 miles, right? So again, at the end of the day, he's going to say, gosh, I'm tired because I jogged 11 miles, right? Displacement, though, remember, you guys, displacement is the distance from your starting point to your ending point. So let's think about his displacement. His displacement is just distance from starting to ending point. So his displacement is going to be 1, 2, 3, 4, 5 miles west. That's why the displacement came out to be -5 miles. All right. I like these drawings a lot, you guys, and as we get farther into the chapter, I'm going to be more insistent that you make these drawings because to make the drawing, you have to understand the concepts, right? And I think similarly, the drawings will help you understand the concepts. All right, so there we go. So that is definitely, that right there is one of your learning targets. I believe the target is worded, be able to calculate distance and displacement if given a written situation. That's what I'm talking about right there. Okay? So basically, you just need to remember that to find your distance, you add up your numbers. To find your displacement, you also add up your numbers, but you've got to watch your negatives. All right? Next example, sometimes I'll give you a drawing or like a little map or something. All right, so here we've got, I don't know if you watch SpongeBob SquarePants, but so we got a few places in SpongeBob's little world, all right? So you can see if you look at the drawing here, we got SpongeBob's house is right here, Squidward's house is here, Patrick's house is over here, and then the Krusty Krab is over there, all right? And then you can see that I've given you the distances between them. So 300 meters is the distance between SpongeBob's and Squidward's. The 200 is Squidward to Patrick, and 500 to the Krusty Krab. All right? So in this example, it says Squidward walks from his house to Patrick's house, to SpongeBob's house, and then finally to the Krusty Krab. So we got to find the distance he walked. So this is one where the drawing is going to totally help us. So let's see. Squidward walks from his house. So here's my starting point. All right? And he's going to walk from there to Patrick's house. That's our first step. And then he's going to turn around and go all the way back to SpongeBob's house, and then all the way back to the Krusty Krab. All right, so there are definitely a few ways you can do this. But remember, the distance is the total length that he walked, right? So the distance is just going to be, well, let's see, we're going to go from here to here. So that's 200 meters. And then he's going to go that 200 meters back, right, plus another 300 meters. These are all meters. All right, and then finally, once he gets to SpongeBob's, he's got to go all the way back, which means he's going to have to go 300 meters, 200 meters, and 500 meters. Okay, so that's how we're going to find the distance. So grab your calculator and add those up. I believe that adds up to 1,700 meters. Okay. Now, to find the displacement, there are two ways you could find the displacement. One way to do it would be to do the same thing. Find your displacement, do the same thing, but watch your signs. So when I do that, okay, let me clean up my drawing a little bit here. So when I find my displacement, I'm going to have, from my starting point, remember, we're going to have negative 200 meters, plus 200 meters, plus 300 meters, plus negative 300, negative 200, and negative 500. Oops, 300, negative 200. These are, again, all meters. All right, so again, grab your calculator and add them up. And those numbers will turn out to be negative 700 meters. All right, so that works. This option here to find displacement works, but as you can see, it's totally a pain. There is an easier way to do it. All right, so the easier way to do it is this. Remember, you guys, the definition of displacement is the distance from starting point to ending point. So really, here's all you got to do to find your displacement. All I care about is where he started. Squidward started his house. He walked around with Patrick and SpongeBob until they got to the Krusty Krab. How far is it from Squidward's house to the Krusty Krab? 200 plus 500, 700 meters. So my displacement is negative 700 meters. All right, that's an easier way to do it. All right. So some of this is equations. Some of this is, just kind of understanding what the numbers mean. All right, this first video is going to go over 20 minutes because I talked for a little bit about sort of the expectations. I apologize. They will not all be this long. All right, so the last thing we need to deal with is position. All right, position tells us an object's location, and I did not, and I wish I had, used the word number line. So when we talk about position, we have to talk about a number line. Position tells you where the object is at on a number line. So here, if I said to you, what's the position of Bob's Triangle Store, then you'd say, oh, well, Bob's Triangle Store is at a position of 12 miles. And, Sally's house is a position of 7 miles. All right. So sometimes we'll have a situation like this where somebody walks around on your number line. So in this one, Bob walks from the Triangle Store. So he's going to start here. And then he's going to walk to the White Castle. All right. So to find the distance he walks, well, you got to figure out how far it is. So there's a couple ways of doing it. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. And find out that he walked 9 miles. The easiest way to do it, though, I think, is to subtract. All right, so it turns out, remember I told you displacement, the symbol for displacement was triangle X? Well, the triangle means change in, and anytime you're trying to find change in something, it's always final minus initial. So in this problem, what is Bob's final position? Oh, it's 3 miles, right? So that's my initial position. And then his, no, I'm sorry, that's his final position. Sorry about that. And then his initial position was 12 miles. So you just subtract. But the important thing to remember is you do final minus initial, not the other way around. Okay, you take the ending position and subtract the starting position, which is sort of contrary to the way you'd think it is. So you end up getting negative 9 miles, right? So there's my displacement. He walked 9 miles west. The negative just means that he walked west. And then you go, oh, well, if he walked 9 miles straight west, then his distance must also be 9 miles, right? Because he went in a straight line. The only thing is you lose the negative sign. All right. Finally, one last example. Sometimes the problems will be a little bit more involved. So this time, Bob is going to walk from the Triangle store to the Quickie Mart and then back to Sally's house. All right. So one option is to solve this like I did the SpongeBob problem, where you find your distances and add them up. That's probably going to be the best bet, to be honest. So our distance, let's see, we got to go from a position of 12 to a position of 15, right? So that's going to be, let's see, 15 minus 12 is 3 miles. Oops, probably can't read that because I wrote it over the word store. That's 3 miles. And then he's going to go from 15 all the way back to 7. So 7 minus 15 gives us negative 8. But remember, your distance can't be negative, so that's just 8 miles, right? So the distance he walked is going to be 3 miles plus 8 miles, which gives you 11 miles. All right. For the displacement, you have two options. You can do 3 miles plus negative 8 miles, right? Would give you negative 5 for your displacement. Or you can just, I wish I'd done that in blue. Pretend this is blue. All right. Or you can just say, well, look, I'm starting at the Triangle store, walking around until I get to Sally's house. So you can also do it that way, just by subtracting. So let's see, our final position is 7 miles. Our starting position was 12 miles. Grab your calculator, 7 minus 12 gives you negative 5 miles. All right, there we go. All right. So, again, I'm sorry that video was a little bit long. I will see you in class.